Hey everybody, welcome back to my channel. This is WireDogSec back with another video for you guys. Today's video we are in TryHackMe. This is Cybersecurity 101 Learning Path, Security Solutions module, and this is Firewall Fundamentals Room. Learn about firewalls and get hands-on with Windows and Linux built-in firewalls. Now again, this is Cybersecurity 101. Therefore, this is geared towards people trying to get into cybersecurity, people who are new to the space. So remember that. Anyway, hopefully y'all are having an awesome day today and ready to learn something. Let's go ahead and dive into it. Hey everybody, welcome back to my channel. Be sure to hit the like button, comment, and subscribe. Once you subscribe, be sure to hit that notification bell. All right, so you know every time I post a new video. As you can see here, most people that view my videos, view my channel, are not subscribed. Now, if you do subscribe, it will help me get into the YouTube algorithm so that we can continue to grow our glorious community here. As always, thank you all for taking the time to watch. Have a nice day and enjoy the video. Task 1. What is the purpose of firewall? We have seen security guards outside of shopping malls, banks, restaurants, and houses. These guards are placed at the entrances of these areas to keep a check on people coming in or going out. The purpose of maintaining this check is to ensure nobody sneaks in without being permitted. This guard acts as a wall between this area and the visitors. A lot of incoming and outgoing traffic flows daily between our digital devices and the internet they are connected to. What if somebody sneaks in between this massive traffic without getting caught? We would also need a security guard for our digital devices then, who can check the data coming in and going out of them. This security guard is what we call a firewall. A firewall is designed to inspect a network's or digital devices incoming and outgoing traffic. The goal is the same as for the security guard sitting outside a building, not letting any unauthorized visitor enter a system or a network. You instruct the firewall by giving it rules to check against all the traffic. Anything that comes in or goes out of your device or network would face the firewall first. The firewall will allow or deny that traffic based on its maintained rules. Most firewalls today go beyond rule-based filtering and offer extra functionalities to protect your device or network from the outside world. We will discuss all these firewalls and perform practical lab demonstrations on a few. And here's a graphic of what they are talking about. So we have unwanted traffic coming from the internet here. It's hitting the firewall. And then from there, it traverses into your network based off of the configuration settings inside of the firewall itself. And then you have allowed traffic going outside of the firewall. Same thing here. Whatever you have configured inside this firewall is going to be allowed in or out of your network. Okay. Learning objectives. After completing the room, you will have a basic understanding of the following areas: the types of firewalls, the firewall rules and its components, hands-on Windows built-in firewall, hands-on Linux built-in firewall. Now, these are what's called software firewalls, okay? They are in the operating systems themselves that you configure. They do have other firewalls that are like external or hardware firewalls like Palo Altos. You have checkpoints out there, Fortinet, right? Those are going to be the firewalls that are like hardware based, right? So like physical devices, a lot of times they'll be placed in like the data center or what have you. Prerequisites, networking concepts. So complete this room if you haven't done already. What security solution inspects the incoming and outgoing traffic of a device or network? Well, that's going to be a firewall, as we just read about here. Okay, kind of acts like a bouncer at a club, right? Security in the club. They're going to check the list to see if you're allowed in, if you're on the name, or if you're on the list, to see if your name's on the list, and then they're going to allow you in inside the club, right? Task number 2: types of firewalls. Firewall deployment became common in the network after organizations discovered their ability to filter harmful traffic from their systems and networks. Several different types of firewalls were introduced afterward, each serving a unique purpose. It's also important to note that different types of firewalls work on different OSI model layers. Firewalls are categorized into many types. Let's examine a few of the most common types of firewalls and their roles in the OSI model here. So types of firewalls, they're talking about stateless, stateful inspection, next generation firewalls, and proxy firewalls. Let's see what they're cooking. Stateless firewalls. This type of firewall operates on layer 3 and layer 4 of the OSI model and works solely by filtering the data based on predetermined rules without taking note of the state of the previous connections. This means it will match every packet with the rules regardless of whether it is part of a legitimate connection. It maintains no information on the state of previous connections to make decisions for future packets. Due to this, these firewalls can process the packets quickly However, they cannot apply complex policies to the data based on its relationship with the previous connections. Suppose the firewall denies a few packets from a single source based on its rules. Ideally, it should drop all the future packets from the source because the previous packets cannot comply with the firewall's rules. However, the firewall keeps forgetting this, and the future packets from this source will be treated as new and matched by its rules again. Stateful firewalls. Unlike stateless firewalls, this type of firewall goes beyond filtering packets by predetermined rules. It also keeps track of previous connections and stores them in a state table. This adds another layer of security by inspecting the packets based on their history with connections. Stateful firewalls operate at layer 3 and layer 4 of the OSI model. Suppose the firewall accepts a few packets from a source address based on its rules. In that case, it will take note of this connection in its stated table and allow all future packets for this connection to automatically get allowed without inspecting each of them. Similarly, the stateful firewalls take note of the connections for which they deny a few packets, and based upon this information, they deny all the subsequent packets coming from the same source. Proxy firewalls. The problem with the previous firewalls was their inability to inspect the contents of a packet. Proxy firewalls, or application layer gateways, act as intermediaries between a private network and the internet and operate on the OSI model's layer 7. They inspect the content of all packets as well. The requests made by users in a network are forwarded by this proxy after inspection and masking them with their own IP addresses to provide um, anonymity for the internal IP addresses. Content filtering policies can be applied to these firewalls to allow or deny incoming and outgoing traffic based on their context. Next generation firewalls, NGFWs. This is the most advanced type of firewall that operates from layer 3 and layer 7 of the OSI model, offering deep packet inspection and other functionalities that enhance the security of incoming and outgoing network traffic. It has an intrusion prevention system that blocks malicious activities and in real time. It offers heuristic analysis by analyzing the patterns of attack and blocking them instantly before reaching the network. NGFWs have SSL, TLS, decryption capabilities, which inspect the packets after decrypting them and correlate the data with the threat intelligence feeds to make efficient decisions. Now, with this TLS decryption capabilities, also known as SSL inspection, it's known as a different word depending on whatever firewall vendor you're talking about. But basically, as it says here, it takes the packet, decrypts it, reads the information in it, and then it re-encrypts it and sends it back, right? Or so continues the process out. That way, it can determine if the traffic is legitimate or malicious, even if it is encrypted, because it has the ability to inspect that encrypted traffic. A lot of times, this can mess with business processes, and they have to add this to like an exclusion list or something like that. Say, hey, do not do SSL or TLS decryption or inspection from this traffic coming from this area of the network and or what have you. Okay, and this is what mostly I see these days is these next generation firewalls. You may come across these other ones, but these are like older ones as stated in this particular task here. But let's continue on. The table below lists each firewall's characteristics, which will help you choose the most suitable firewall for different use cases. So stateless firewalls, basic filtering, no track of previous connections. Stateful firewalls recognize traffic by patterns, etc., etc. You can read the table here. So pause the video, take a look at this, understand which firewall does what, because you may come across this in the real world or on an exam where it asks you the difference between each of these different firewalls. So make sure you are paying attention to this particular area here. Even if you don't end up configuring firewalls in your work environment, at least you'll have knowledge of the capabilities of the types of firewalls. That way you can make an educated decision, right? Or tell if someone is not applying security best practices and such. All right, so question time. Which type of firewall maintains the state of connections? Which type of firewall offers heuristic analysis for the traffic? Which type of firewall inspects the traffic coming to an application? Pause the video, try to answer these yourself, come back to the video. Okay, let's take a look here. Which type of firewall maintains the state of connections? All right, and that should be the stateful firewalls. So let's type that in there. And which type of firewall offers heuristic analysis for the traffic? Well, that's going to be the next generation firewall here. It says right here, identify anomalies or anomalies, sorry, anomalies based on heuristic analysis. So let's go ahead and plug that one in there. And it says which type of firewall inspects the traffic coming to an application. Okay, and that should be the proxy firewall that does that. So let's go ahead and plug that in here. It just provides application control. All right, also, if you get stuck on these, you can hit these hints here and it'll give you some more information, right? Known as the application level gateway. So we're done with that one. Now we're going to continue to task number 3, rules and firewalls. Says a firewall gives you control over your network's traffic, although it filters the traffic based on its built-in rules. Some customized rules can be defined by various networks. For example, there would be networks that want to deny all the SSH traffic coming into their network. However, your network would have a requirement to allow SSH traffic from a few specific IP addresses. The rule allows you to configure these customized settings for your network's incoming and outgoing traffic. The basic components of a firewall's rules are described below. So you have source, address, destination, port, protocol, action, and direction. All right, so be sure to read through this, understand what's going on. Also, when I was talking about the different types here and also up here for the purpose of the firewalls, right? So the ones that are on the operating system itself, those are going to be what's called host-based firewalls, right? So they're on the host operating system, and then the ones that are external or like physical devices, like Palo Altos and such, those are going to be your network-based firewalls, all right? But anyway, let's continue on here. Types of actions. The component action from a rule indicates the steps to take after a data packet falls under the category of the defined rule. 3 main actions that can be applied to a rule are explained below. Allow. A rule's allow action indicates that the particular traffic defined inside the rule would be permitted. For example, let's create a rule with an action to allow all outgoing traffic from our network for port 80 used for HTTP traffic to the internet. And this is what the rule would look like here. So we have action allow, the source is going to be this here, destination any, right? So they want to allow HTTP traffic to the internet. And then protocols, TCP, port 80, and then outbound for the direction. Denies rule. Action means that traffic denied inside the rule would be blocked and not permitted. These rules are fundamental for the security team to deny specific traffic coming from malicious IP addresses and create more rules to reduce the threat surface of the attack, or sorry, the threat surface of the network. For example, let's create a rule within action to deny all incoming traffic on port 22 used for remotely connecting to a machine via SSH on our critical server. So it will look something like this. Action deny, source any, destination, protocol, port 22, direction inbound. Forward. The action forward redirects traffic to a different network segment using the forwarding rules created on the firewalls. This applies to firewalls that provide routing functionality and act as gateways between different network segments. For example, let's create a rule with an action to forward all incoming traffic on port 80 used for HTTP traffic to web server, this 192.168.1.8. So action forward, source any, destination is going to be this 1.8 IP. Protocol TCP traffic, or sorry, port is going to be 80 and direction is going to be inbound. Directionality of rules. Firewalls have different categories of rules, each categorized based on the traffic directionality on which the rules are created. Let's examine each of these directionalities. So you have incoming, outgoing traffic here in this graphic. Incoming or inbound rules. Rules are categorized as inbound rules when they are meant to be applied to incoming traffic only. For example, you might allow HTTP traffic on your web server. Outbound rules. These rules are made for outbound or outgoing traffic only. For example, blocking all SMTP traffic from all devices except the mail server. Pretty straightforward. Forward rules. Forwarding rules are created to forward specific traffic inside the network. For example, a forwarding rule can be created to forward the incoming HTTP traffic to the web server located in your network. All right, question time. Which type of action should be defined in a rule to permit any traffic? What is the direction of the rule that is created for the traffic leaving our network? So go ahead and try to answer this yourself. Come back to the video. Okay, so let's take a look here. So we're looking at permitted traffic. All right, so if we go back up here, where it talks about that, so it's going to be this allow, and the second one should be a deny. So let's go ahead and plug these two in here. So you're going to permit traffic, right? And then, so what is the rule that's created for traffic leaving our network? That's going to be the outbound rules. So remember, so outbound means traffic that's leaving the network, okay? Outbound traffic only, all right? Or outgoing traffic only. Task number 4, Windows Defender Firewall. I already have the machine started up, as you can see here, split screen is showing. So read these instructions here if you plan on doing this particular task here. You can start the machine, you can use split screen like I am here, or you can log in directly using VPN, RDP credentials, etc., etc. All right, so we're going to go over this Windows Defender Firewall here. Windows Defender is a built-in firewall introduced by Microsoft in the Windows OS. This firewall contains all the basic functionality for creating, allowing, or denying specific programs or creating customized rules. This task is designed to cover some of the essential components of the Windows Defender firewall, which you can utilize to restrict your system's incoming and outgoing network traffic. To open this firewall, you have to open the Windows search and type Windows Defender Firewall. So if we want to do that, we just go down here and just type in Windows Defender Firewall. There we go. Okay, so we have that open. So the Windows Defender Firewall's homepage shows the network profiles and the available options. This is the main dashboard with all the options for the firewall. So we can see that on our screen as well. Available options. Network profiles. There are 2 available network profiles. Windows Firewall determines your current network based on network location awareness (NLA) and applies that profile firewall settings for you. We can have different firewall settings for each of them. Private networks. This includes the firewall configurations to apply when connected to our home network, guest or public networks. This included the firewall configuration to apply when connected to a public or untrusted network like coffee shops, restaurants, or similar. For this example, when connected to public networks, you can configure firewall settings to block all incoming network connections and allow only some outgoing connections that are essential for you. These settings will apply to the public network profile and will not be implemented when you are in the private home network, which is good because you don't know what's on, the coffee shop's network. It could be hacked for all you know, or there could be some funky stuff going on there. To allow or disallow any application in any of your network profiles, click on the option highlighted as one in the screenshot. This will take you to the page listing all the apps and features installed in your system. All right, so this is what they're talking about here. So you can check mark the ones you want to allow in any of your network profiles or uncheck those if not needed. Windows Defender Firewall is turned on by default. However, if you want to turn it on or off, you can click on the option in number 2 here in the screenshot. All right, so you can go in and check mark whatever criteria you want to set for this particular firewall here. So we're gonna hit this back button here, and then section 2, you can go ahead and go in and turn it on, turn it off. All right. A lot of times I have seen these turned off in the corporate environment because if you turn this on, it could cause a lot of issues because unfortunately, a lot of organizations don't document everything that's on each individual host and what they need to communicate to. So they turn this off because it can interfere with legitimate business processes. Like it can go in and block traffic to a legitimate business application or something like that. It can be a big hassle to manage these host-based firewalls or firewalls in general. A lot of times, the security teams don't have the resources available to properly implement this firewall. But let's go ahead and continue here. Since this will take you to the settings of both network profiles rather than completely turning it off, which Microsoft doesn't recommend. You can also block all incoming connections. You can also click on the Restore Defaults highlighted section 3 in the screenshot from the main dashboard anytime you want to restore the firewall's default settings. So if you went in and you messed it up on accident, just click this here. You want to restore defaults. There you go. There's a prompt there. So let's go back. And it says custom roles. Windows Defender Firewall also allows you to create custom roles for your network to allow or disallow specific traffic as needed. Let's create a custom role to block all outgoing traffic on port 80 or 443. After completing this rule, we will be unable to browse any website on the internet as the websites are working on port 80 and 443, which we will be blocking. Before creating this rule, let's test if we are able to visit a website. For testing, let's visit this website here. So I'm going to just copy and paste. So let's go ahead and fire up our trusty Internet Explorer here, everyone's favorite web browser. All right, so that's starting up now. And we should get something similar to the screenshot here, right? So once you try to go to it, after we put in the firewall rules, it'll be blocked and we won't be able to see it. But let's go ahead and go to this. If it doesn't let me paste, interesting. Okay, whatever. I'll just manually type it in on HTTP. There it is. And it says that you can see this page, you're connected to the TryHackMe, um, et cetera, et cetera. Yeah. So let's go ahead and continue on. It says to create a custom rule, choose the advanced settings from the available options in the main dashboard. This will allow, or this will open a new tab where you can create your own rules. So let's flip back over here real quick, and then advanced settings. All right, so that's firing up. It says note the rule created below is already available inside the attached VM. If you want to test it, you can create it on your Windows host machine or any other machine. Okay. So it says you can see the available options to create inbound and outbound rules right here on the side. The side panel here is inbound rules. There we go here. There's quite a few in here already. All right, then we have outbound rules. Okay. Now what they're saying is if you wanted to um, block this connection, right? So you would put in a rule to block outbound connection on port 80 and 443, right? So yeah, if you want to do that, just click new rule and then go in and just edit what you need to edit here. So program, um, port, predefined custom rule. All right, so let's see here. Let's create an outbound rule to block all outgoing HTTP and HTTPS traffic. Right, so we're in outbound rule already. And then it says click new rule, which we've already done. It will open the rule wizard. On the first step, you're going to click custom rule. Okay, can't see next, but we're going to click it down there. Second step, select all programs. Okay, click next. Okay, and it says that select the protocol as TCP. So we're going to drop this down to TCP. It says keep local port as it is, and then change remote port to specific ports. So we have remote port here, specific ports. We're going to type in 80 and 443, like so. So write the port numbers in the field, which you've already done. Separate the port numbers by commas. Please don't leave spaces between them, which I've done. So let's go ahead and delete that space. All right, so we're done that. In the scope tab, um, okay, yeah. So we're going to click next here. All right. So in the scope tab, keep the local and remote IP addresses as they are and press the next button. In the action tab, enable the block connection option, click next. All right, so any IP address, we're gonna hit next, and then block the connection. We're gonna block outbound to those ports. And it says in the profile tab, we keep all the network profiles checkmarked. Lastly, the final phase is to give your rule name and an option or optional description. Press the finish button. We can see our rule is there in the available outbound rules. Okay, so we're gonna leave everything in there, check marked. Next, we're gonna use the same thing here as they have. So for the name, see block HTTPN HTTPS if I can spell. There we go. So we're done with that, and then all right, so we should be good. Now let's test our rule by browsing to the same website we did earlier. We get an error message saying we cannot reach this page, so we're just gonna hit refresh. Yep, it says content for the website listing being blocked, blah, 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 whatever. Close that. Now it says can't reach this page, okay? Exercise. The security team noticed suspicious incoming and outgoing traffic on their critical Windows system. They created rules on their Windows Defender firewall to block some of their specific network traffic. You are tasked to answer a few questions given at the end of this task by looking at the created rules. All right, so let's see here. What is the name of the rule that was created to block all incoming traffic on the SSH port? A rule was created to allow SSH from one single IP address. What is the rule name? Which IP address is allowed under this rule? So go ahead and try to figure out this yourself. Come back to the video and we will continue on. Make sure you are in inbound rules because we're looking for incoming traffic on port SS or SSH port, okay? So if we take a look at this core op one here, we scroll over. we can see that it's enabled, actions block, and then if we keep scrolling, we can see that local port is going to be 22, remote is going to be any. All right, so that looks like the one we need to plug in here. So infra, it was just infra ops. Sorry, core op is what I'm looking for here, not infra. So core op should be that one, and then a rule was created to allow SSH from one single IP address, and we saw that in here as well. So we have allow, which is the one underneath it, should be this one here. And to go through and review the rules, we can see that this is the one that we need to plug in here. It's allowing those connections to one single IP address. So this one should be infra team. And then it says which IP address is allowed in this rule, which we just saw there was that 192 IP address. There we go. So 192.168.13.7. All right. Task number 5, Linux IP tables firewall. In the previous task, we discussed the built-in firewall available in the Windows OS. What if you are a Linux user? You still need to control you still need to control need control of your network traffic. Linux also offers the functionality of a built-in firewall. We have multiple firewall options available here. Let's briefly review most of them and explore one of them in detail. So we have NetFilter. NetFilter is the framework inside the Linux OS with core firewall functionalities, including packet filtering, NAT, and connection tracking. This framework serves as the foundation for various firewall utilities available in Linux to control network traffic. Some common firewall utilities that utilize this framework are listed below. Talking about IP tables, NF tables, and firewall D. So go ahead and pause the video and read through this. See what we're talking about for these. UFW, which is uncomplicated firewall, as the name says, eliminates the complication of making rules in a complex syntax in IP tables or its successor by giving you an easier interface. It is more beginner friendly. Basically, whatever rules you need to or need in IP tables, you can define them with some easy commands via UFW, which would then be configuring your desired rules in IP tables. Let's have a look at some basic UFW commands. Down below, to check the status of the firewall, you could use the following command below. So you will need sudo UFW status. This is status inactive. If it declares inactive, you can enable it by using the following command. So the same thing here, sudo UFW enable, turn it on. To turn off the firewall, type disable instead of enable. Below is a rule created to allow all the outgoing connections from a Linux machine. The default in the command means that we are defining this policy as a default policy, allowing the outgoing traffic unless we define an outgoing traffic restriction on any specific application in a separate rule. You can also make a rule to allow or deny traffic coming into your machine by replacing outgoing with incoming in the forwarding or following command. So sudo UFW default allow outgoing. All right, you can deny incoming traffic at any port in your system. Let's say that you want to block incoming SSH traffic. We can achieve this with the command UFW deny 22/TCP. As you can see that we first specify the action, which is deny in this case. Furthermore, we specify the port in the transport protocol, which is TCP port 22 or simply 22/TCP. To list all the active rules in a numbered order, you can use the following command. So they have sudo UFW status numbered. To delete any rule, execute the following command with the rule number to delete. So sudo UFW delete 2 and delete that rule out of there. These different utilities can be used to manage NetFilter. Choosing the right utility for the Linux OS depends on multiple factors, such as familiarity with the OS and your requirements. You can test your knowledge of Linux firewalls by creating some rules defined in this task and testing them to ensure that they are working as expected. You can go ahead and try that on your own. You can try that on your own Linux VM, or you can fire up the attack box and mess around with it there. So I encourage you all to go ahead and try to do some testing yourself if you're unfamiliar with this process or just want to play around with it to get your hands on. All right, let's take a look at these questions. Which Linux firewall utility is considered to be the successor of IP tables? What rule would you issue with UFW to deny all outgoing traffic from your machine as a default policy? Answer without sudo. So go ahead and try to answer these questions, pause the video, and then come back. All right, so let's take a look at this first one here. the successor of IP tables. If we scroll up a little bit, we can see this is NF tables. So it is a successor to the IP tables utility with enhanced packet filtering and NAT capabilities. It is also based on the network filter framework. So let's go ahead and plug that one in as our answer. It says, what rule would you issue with the UFW to deny all outgoing traffic from your machine as a default policy? So we're going to go back up here, see what they're talking about with deny. So it would be something like this. And actually, it will be this one. So we're going to change allow to deny. So we want this deny, and then it was outgoing. I believe that was it. Yep, and we are done. So that wraps up this room. If you enjoyed the video, hit the like button, comment, and subscribe to the channel if you're enjoying the content. Now, as I said before, you may come across these firewalls throughout your career, whether you be the one that's configuring these firewalls itself or just taking a look at the configuration settings. It's important to understand how these firewalls work, the differences between them, and the differences between the network and host-based firewalls as well. Feel free to do some more deep diving if you enjoyed learning about firewalls. Okay, so get on your favorite AI chatbot out there, ask it some questions, get on the Googles out there, get on YouTube, start doing your own research for things. Okay, this is just the surface of this particular area. But thank you all for taking the time to watch my video. Have a nice day, and I will see you later.